Hi. Oh my god, dude. Son, why are these so difficult to do? Where's your Marcus? The kitty. Move. I'm doing wall sits, kitty, move.
Talk?
雪花飘飘飘，北风萧萧。
Okay. I guess it works.
What works?
Your audio should transfer. Oh, I shouldn't like that.
What works?
Your audio should transfer. Oh, I shouldn't like that. Okay. What are we doing?
I don't know. I mean, am I gonna be the only one who's like listening to you? Or does anybody know you're gonna be streaming?
Nope. Honestly, I hope they just get the notification. Otherwise, I'm just gonna...
Oh, wait, I almost forgot my phone. Hold on, I'm walking back to my computer right now. Could do just definition problems because it's the free response section, so maybe some just definition problems.
Okay. What does that
Wait,
mean?
can you send me a link to your YouTube channel?
I did. It's in your Discord.
Oh, I did not look at it. Okay. Oh yeah, I can hear myself.
Did I do these papers?
Dude, I sound so weird in the stream.
Oh, I
Oh.
did this. I definitely did. I did this yesterday. I did this one. I also did this one.
There's 3 watching.
I did this one today. Yo. I did all of these. TS is cooked.
Why don't you just you did all of them? Why don't you just look up ACE physics definition question? Free response definition questions.
Holy. Yo, W Google. Like this?
Yeah, I think your stream is delayed by a lot.
Yeah, it is delayed.
Yeah, by like 15 seconds, probably 20, maybe.
That's fine. Okay. Maybe I didn't do all last year's. Maybe I can look at those. Honestly, if you want me to just go through, I can just go through each one. Each one, okay.
I don't know. I think rather than like a term, we should do like the laws.
The laws, Kirchhoff's first law, and
Sure, like Ohm's law, if that's a thing, that's gonna be on there.
yeah.
Kirchhoff's laws, and if there's any other laws, I don't
Yeah.
remember.
There's pretty much in terms of like current electricity. So like a current. Oh god, why is this so thin? Okay, wait, let me change color.
Wait, so they're asking like on IC define velocity. They like to say per unit something, right? They like to write that as their
Oh wait, I'm
definition.
stupid. Can you look at my screen
Mhm.
like this? So it's real time
Yeah, sure.
on Discord.
Yeah, I'm looking.
Okay. Oh wait, no,
But
that's
they like for you to put. Oh,
okay. What were you saying?
they like for you to put per unit, right? Like for velocity, it would be like distance per unit time,
Yeah. I mean,
or is
yeah.
it
That's the
displacement?
most. I think that's the most complete answer. So for example, like define velocity, you could say um the change in distance per unit of time. Because per unit of
Okay.
time in this case it would be seconds, right? One per 1 second. Let me go over the Kirchhoff's law. Okay, so current stuff. So there's one is like define the ohm, which is basically this, which is resistance, right? I looked in the mark scheme, and the shorthand notation was just volt over ampere. And
Hmm.
in other words, in plain
Okay.
English, you should say volt divided by ampere. V over
You
A,
get
right?
points for taking that.
Yeah, I think so.
Yeah.
That's what the mark scheme said. I hope. And then there's define Kirchhoff's first law. So define Kirchhoff's first law. So in terms of Kirchhoff's law, the thing you want to memorize is that first contributes to charge, and then the second contributes to energy. So what does this mean? So in terms of uh, law, when you think of charge, remember that current is charge per unit of time, right? So when you think Kirchhoff's first law, you want to think conservation of charge. So then you talk about how the current is preserved, right? And then you can write your final answer, which is like the sum of incoming current is equal to the sum of outgoing current at a junction, which is simply, if you have like a point here, and you have that, right? You have A, B, and C. A plus B is equal to C. Does it make
So you could
sense?
just say current into a junction is equal to the current out of a junction.
Yeah, basically.
Okay.
I can try and find like the exact mark scheme, but I've done way too much, I think. So I don't know where it is. Oh, right here. So it's 2-1.
C.
6A. The sum of the currents entering a junction is equal to the sum of the currents leaving. The
So
sum of
you
the
have to say the
currents.
sum.
Yeah.
Sum of the currents entering a junction is the sum of the is equal to the sum of the currents leaving.
Yeah.
Guess that makes sense.
Yeah. And then it says here Kirchhoff's second law, which is just volts. Um, we'll look over that right now. So in terms of Kirchhoff's first law, so that's Kirchhoff's first law, and then for Kirchhoff's second law, for Kirchhoff's second law is the conservation of energy. And if you want to think about it, if you want to think about the units that you use in terms of electricity or like circuits, we know that the volt is equal to the energy per unit charge. In other words, it's joules over charge, right?
Joules per coulomb.
Joules per coulomb. Yeah, same thing. So this is what we're looking at because we're looking at energy. We're conserving energy, so we're going to look at the voltage, right? So then if you look here, we can say that this is kind of like one of the first things you learn. The sum of the potential difference is equal to the sum of the EMFs, I'm pretty sure, right?
Yeah, I just remembered it.
Yeah, so this is the batteries that you get, right? And then this is the volts across, this is like the volts across a component. I'm pretty sure that's it, right? So in
Yeah.
6b it says how I'm pretty sure I downloaded this. I did this yesterday.
Crazy.
I think I did do this yesterday. Wait, I downloaded all of Mark's schemes. Am I stupid? I guess, bro. Okay,
Yeah,
whatever.
you're probably just gonna fail.
Okay, back to this. So 6a and then 6b. Use Kirchhoff's laws to show that the total resistance RT is given by this. So essentially, like, the potential differences, which is here and here, V1 and V2, is going to be equal to the voltage provided by the cell or the battery.
Yeah.
That's a terminal PD. Yeah.
Wait, scroll back up.
Wait.
As RT is equal to.
Yeah, because this is the total resistance. The terminal PD is like the voltage that is not in the battery, basically. The terminal PD, I'm pretty sure.
It's so. Why does the RT not include little r?
It's because it's asking for the external circuit.
Oh, external circuit. Okay.
So it's everything except for the cell.
So if it just said circuit, it would include the battery. But if it says external circuit, it's
Yeah.
everything but the battery.
Yeah. I'm pretty sure that's what terminal means. It just means everything except for the battery. Unless I'm genuinely tweaking, but that is my understanding. Okay, yeah, whatever. Is there anything else in this? Unless you want me to just do. Oh, I do
Are there
want
any
to.
other laws?
I don't think so. I think it's just 1 and 2 that were tested on. Okay, so I want to go over nuclear.
Oh, yeah.
I'm just.
I think
It's
all
just
I need
pure
to
on memory.
know beta minus radiation gives off an antineutrino or a
Yeah.
neutrino? Antineutrino.
Yeah, I'll go
Okay.
over the main stuff and like how I memorize it. So first thing is a flowchart. So the types of particles. So we have the hadron. So the hadron is makes up two categories: baryons and mesons.
Are on mode? Sorry. Right.
All right. So this is three quarks slash three antiquarks. And then mesons are one quark slash one anti. And one anti, sorry. These are not or. This is the composition. So then this is the general idea for hadrons and then baryons.
Wait. A hadron is like the protons and neutrons, right?
Can you say that again?
The hadrons are the protons and the neutrons, right?
Yeah.
And then the leptons are like the positrons and the electrons.
Yeah. Wait. From my understanding, I learned that hadron was a fundamental particle.
Yeah, yeah. Wait. Isn't it leptons? Leptons are fundamental particles because you can't go smaller than an electron or a positron.
Yeah. Okay, wait, I'm
Yeah,
stupid. Yeah,
so
this
leptons
is
are the
like a type
fundamental
of
particles.
particle. Yeah. So, and then the other one is leptons. And then these just include like electron and positron, because you want to associate these in pairs because these are opposites of each other, right? This is the beta minus, this is the beta plus, and then you have neutrino and antineutrino. I should stop drawing arrows. These are not right. But like these are like pairs. This is VE and this is antineutrino. Yeah. And then other, this is like the general flowchart or the types of particles. So these baryons, right? These three quarks, these include like protons and neutrons, etc. For mesons, I'm not entirely too sure. I don't think you have to memorize anything. They just might give you things. And then you want to memorize the chart for the quarks, which are the other fundamental particles. So these here, leptons and quarks, these are fundamental particles,
Fundamental. Yeah.
which means that this is actually a definition problem in terms of nuclear. So fundamental particles cannot be divided. I think that's the correct terminology. Not like you can break them down, but you cannot be divided further. So yeah. So quarks, there's a big table that you technically have to know, but
We are not knowing that.
you only need to know 6 of the names. And then you can memorize one method, and then you can get everything else. But I just might be an intuitive guy, so we'll see. All right, so you want to memorize just 6 of them, kind of. So we have the up, right? The up one. And then we have the top, and then we have the charm. So the way you want to memorize these is that these are all the plus 2/3s charge. These are the quarks with the plus 2/3. And then you want to memorize their partner, their couple, their pair, which is up. What is the intuitive opposite? Down. and then top, and then bottom. And then charm, this one's a little confusing, but you can just memorize that as strange. And these charges are just going to be -1/3, -1/3, and -1/3. So they basically just repeat over each other. Oops. The main thing is that you also have anti-quarks. So this is just the antiparticle of the quarks. So it is technically a fundamental particle. So when you do antiquarks, the only thing you need to do is take the quark, right? Take the quark that you're trying to become an antiparticle. Add anti quark. Negate the charge. And then that's your anti-quark. So for example, if we take up, take the up quark. If we take the anti-quark, we take the anti-up. Right? This is the anti-up quark. And then it has a charge of negate the charge, so plus 2/3. And then we turn it into 2/3. So then this is our anti-quark. So the same thing with down. So anti-down is going to be plus 1/3. Does that make sense?
Wait, you said anti-down? What's anti-down?
So if you take anti-down, we take anti-down, right? That's the name, and then we negate the charge. So even if it's negative, we take the negative of that, and then a negative and a negative becomes a positive, right? Two negatives makes a positive, always. So
What
it
I'm
becomes
saying.
1/3. So an anti-down has a plus 1/3 charge. It's relatively easy to memorize because these are all the same charge, as well as these ones.
Yeah, and the ups.
Yeah, the
The
ups.
ups are up just makes sense to be positive, and then also
Top.
it makes sense for ups to have a greater numerator
Yeah, like the greater
because
magnitude.
they're up.
Yeah.
So they're up in positive charge and up also a bigger numerator.
Yeah. I think there's like one more thing, but I low-key like don't want to go over it. Maybe I should. Oh, I didn't go over writing equations. I just assume you guys know that. Okay. There's one thing for writing equations though that I want to go over. So let's say we have beta minus decay. So beta minus, if we have, actually it's better if I just take a problem. Take this. Nuclei of a copper. Oh wait, this isn't even an equation. Why is this nuclear section so short? This is only 3 marks. That's what?
Well, I guess we don't even know it.
Yeah, I guess this year was honestly like, okay, I actually like this. So clearly I came very prepared today. So all right. And I omitted the main question I was trying to do. All right, so we have a nuclei of an isotope of samarium, right, Sm, which contains 62 protons and 85 neutrons. So we have AZX, AXZ. So in terms of nuclei notation, so remember that in this case, A corresponds to the nucleon number. Which is simply, is this color hard to see in?
Eh, it's fine. I guess green is better. Green giant.
Z is proton, and then X is elements, right? So to get the nucleon number, we want to add these two. So 62 plus 85 is going to be equal to 147. Yep. So 147 SM, that's the name, and the number of protons, which is 62. And that should be our answer. This isotope of samarium is radioactive and decays by many particles. I'll come back to this question. To BI. This isotope decays to an isotope of neodymium. Give the radioactive decay. Okay, so we have SM. Actually, I'll write out here. So we have SM. 147, 62. And then what we're going alpha decay.
Alpha
So
decay.
alpha decay,
Alpha particles are like 4-2, right?
yeah. So alpha particles are just going to be 4-2. So the special thing about alpha particles is that there are only 4 neutrons and 2 protons, and they have 0 electrons. So what this means is that they have a +2 charge, and they are quite heavy because they have. Oh wait, I'm being stupid. 2 neutrons. Sorry. They have a +2 charge, right? So the total mass is 4. So yeah. So we take this 147 and this 4, we subtract it. So we get 143. Because 4 plus this is equal to 147. And then we do the same thing down here. And then neodymium. And I'm pretty sure that's it for alpha decay. Let us look at the thing.
Wait, are you gonna do a beta minus or a beta plus one?
Yeah, I need to find it.
Okay.
I think it was this one, right? And then 2, 3.
Dude, that's what I said.
All right. Yeah, so for this one, they just tell you that this is it. Yeah, this is all you need. Wait, the rest are looking useless. I need this though. I don't know, go back here. I think there was one from last year. Hey, beta minus. Okay, I'll steal this. It's 2, 1. I remember this problem. Okay. So this is beta decay. Sorry guys, I did the alpha instead of the beta. Whatever. Alright, so we know that tritium is radioactive and undergoes beta decay and forms an isotope of helium. Gamma radiation is not emitted during this decay. And then you want us to write the thingamabob. Okay, so when we have hydrogen to helium, let's do the beta particle first. So since we know that it's beta minus, it's going to be a -1, 0. it just has like a -1 charge and 0 mass. In terms of helium, we want it to, if we say this is x, right? X minus 1 is equal to 1. So it turns out this becomes 2, and then this remains 3 because the thing doesn't change. The total mass doesn't change. They omitted the beta minus, but technically it's implied. So in terms of beta decay, beta decay, if you have beta minus, you emit an electron, I think. And since this is negatively charged, right? You want to say this negative is as in like a naught, right? And then this naught becomes an anti, and then you can say that this becomes an antineutrino as well. Well, it doesn't become an antineutrino, sorry. But it's like, since this is, the electron is negative, we also emit an antineutrino. Does that make sense? So like if it's beta plus decay, we have a positron because it's positive. And then since it's positive, there's no anti, so it's just going to be a neutrino.
Understand it now.
You got it?
So just whenever you see the beta, well, if it's beta minus decay, whatever you see the beta, you just do 0, -1.
Yeah, 0,
If it's
-1.
beta plus, you just do
If it's
0
beta
and 1.
plus, yeah,
And then
0,
fill
1.
in the... Yeah, this is like... That's a lot easier than I thought it was.
Yeah, and then in terms of particle X, they ask for here. So we know it's beta minus, so it's going to be antineutrino. How many people are watching my stream? Genuinely curious.
17.
Holy.
1. Son.
They all left.
Yes. 3 people just popped in, bro. They're not real ones.
Eh.
It's okay, we're gonna pass.
Yeah, we are gonna pass.
Yeah.
Alright, that's nuclear.
Gosh.
There's this graph stuff. So I honestly forgot some of this. I think it was this one, right? Oh. Yeah. Okay. So in terms of these graph stuff, like they might give you a graph. Before.
Hey, this is... Hold on. Ah, dude, he explained this in class. Like, I literally asked him about this too.
Yeah.
Isn't it like alpha part or beta radiation energies include the energy from the neutrinos and antineutrinos,
Oh yeah.
and that means that for beta radiation, the kinetic energy varies because of the energy in the neutrinos and the antineutrinos. And since there's no neutrinos and antineutrinos in the alpha particles, like the alpha particles are constant, only have one
Yeah.
kinetic energy.
Yeah. I'm pretty sure that's right, yeah.
I don't know how I explained it would like get all the marks.
I think that's right though. So
it was like that thing where the length of the lines had all the same length in the
yeah,
alpha
I know
particle.
it's like this one, right?
That black circle.
I know everything else is like black, right?
Yeah, it was
You know,
like looking through a microscope. It was like a black circle, and then
yeah.
there were lines coming from the bottom middle. Yeah, exactly. And it was like all of them are the same length because there's, it's just the alpha particle. There's no other particles. It's constant energy.
Yeah, so in terms of like beta decay, these things create a continuous.
Oh, that's what it is. That's what the word is. That makes no sense to me. What is it? Continuous is like, what does continuous mean?
It just
Like
means that,
constant?
yeah, like it's connected. I
Yeah,
think
and then
I think this
discrete
one
was
has it.
like, it varies, right?
Yeah.
Dude, I don't know.
The
They just picked words, I feel like.
continuous, like think about it like a continuous function. So in terms of like beta decay, um, we have a graph. I think it looks like this because these are all the continuous things. What are the axes? Kinetic energy, and then number, right? Number of particles, yeah. So this is this, and then for like alpha decay, it's what they showed there. Right? Yeah. No arrow. So essentially this continuous can be attributed to the neutrinos and the antineutrinos that are also emitted during beta decay. Or like the other fundamental particles, you know. And in terms of alpha decay, the only particle that is being emitted is the alpha particle. So it's low-key like kind of constant, you know.
Mhm.
All right. I think that's pretty much all of nuclear. I'm gonna be honest.
Yeah. So, I mean, and that's the entire race exam actually. So,
Yeah. Good luck
I think we're
tomorrow.
done.
If you get lucky and the nuclear section is 11 marks, you can probably pass, right?
Real.
Yeah.
Wait, there's two watching now. There's two watching now. Unless
Real?
that's you. Yeah, I don't know if that counts. I don't know
Yeah, that's
how
probably
it
me.
works.
Are you watching my stream or are you watching the Discord?
I'm watching your. Well, oh, now there's three. So there's at least one other person.
Yeah.
I'm watching the Discord.
Okay. Yeah, I don't want you to have any delay.
Oh, now there's two. I think they probably heard me and then they left.
Yeah.
Well, I'm a little bit
You have like
intimidating,
negative
I guess.
aura, you know.
Oh, oh, yeah, no.
Yeah, yeah.
No.
Alright, should I just do a paper? I don't know.
I don't know. Scroll through some slowly. Or you wanna
I
what
did this
website are you
yesterday.
using to look at?
So if you search up Ace past papers, there's like a Papa Cambridge thing.
It's past papers. Yep, oh, Papa Cambridge. The first thing that shows up is marine science. What's the subject code for physics?
It's 9702.
Boom. Past papers for physics. I should just do 20. Well, it would be best to do like 2022, right?
I don't know. I low-key like, so you know like the packet of love he gave, which has problems from like 2015 to like 2023. A lot of those problems I like already saw, so it feels kind of bad for me if I look at it, in my opinion at least.
I don't even know what you're talking about.
Okay,
I'm just
whatever.
gonna look at
I'm just LARPing.
2022 October, November. Oh my gosh. Forget like every country gets a different paper or
Did I
every
do
like
this
area.
one? I did do this one. No, I did that problem. I don't think I did.
All right, I'm gonna do November 2022 question paper 33.
Send the link.
Oh wait, is question wait 30? What the like when it says 41, 42, 43? That's paper one, paper two, paper three, right?
Yeah, for region one.
So I should be
It should start with a
looking
two,
at
like 2-1, 2-2, 2-3, 2-4.
no, I don't care about the region. I mean like the second number is indicates the paper, right?
The first number does.
Oh, the first number is the paper. You sure? Because it goes up to 5.
Yeah, because there's 5 papers for A level.
Oh, I'm looking at. So I should only look at 1, 2, 3 then. Or well, 2. Right? We're doing paper 2.
Yeah.
Okay, so I'll just do like November 2022. Question paper 23. Did you get that?
Wait, can you say it again?
2022. Yeah, October, November. Question paper 23. I'm pretty sure. So like that's it.
Uh-huh.
What's the first one?
Yeah, I don't think I did this one. Oh, we did this in class. Remember this one?
What was the first question? Make sure we're on the same. Yeah, we're on the same paper. Okay, I'm just gonna look through it and see if there's anything that like recurs. The SI base unit of alpha. Oh, wait, that's so easy. Because they literally give you the... Right? That's light. That's actually so light. Because they give you the units of Q, R, and L. So they basically just give you the answer. That's why it's only 1 mark.
Yep.
And then E is 15 because R is to the power of 4, which means 8% plus 4% plus 3%. Yeah, it was 15. Okay. Whatever, the calculation's probably easy. Number 2 is just 2 VAT, right?
Yeah, I think so. That's like kinetics.
At least part I. AI is Suvat.
This is moments. And I assume up thrust, right? Oh, spring. There's up thrust. Longitudinal.
Hey, look at 2 part 2. Or 2A part 2. 2A part 2 is just what? F equals T minus W?
Yeah.
Okay.
Should I do this
Okay.
or are you looking at through it?
I'm looking at 2B part 1 and 2. I think part 1 would be easy because I mean it's just Suvat again, and then for B part 2 you would just have to
Suvat TX.
I don't know because the piece of metal would be moving up with the rocket,
Yeah, it is.
but it doesn't have any thrust anymore, so it would just fall eventually. So your acceleration would just be gravity.
Yeah. This is 3 marks, so I assume that it's not as intuitive. But yeah.
Well, the principle of moments. This was easy. This was easy, and I don't know it. What's the principle of moments? Like I know it, but I don't know it formally. You know what I mean?
Yeah. So to formalize it, it's like the sum of clockwise.
Oh, so this is literally just. See, like this doesn't.
Equals the sum. Yeah.
This is equilibrium basically. is what the
Basically, yeah.
principle of moments is. Yeah, I don't like how they call it principle of moments, but it is what it is, I guess.
And then I think for this one, you just say like in a closed system.
But yeah, in a closed system. Is 3B easy? Isn't it? Is there anything like it's just a standard equilibrium problem, right?
Okay, so it does say about the same point in equilibrium.
The spring, yeah, springs. Honestly, spring, it's wraps. I'm not doing the spring stuff. I don't think so. Lolo, what are you doing?
Well, um,
Okay, but spring constant is like the slope. It's the slope of the line, right?
yes. And an F versus X. Um,
But it's in what's the units of spring con? Does spring constant have units or no? It's like you see how the x-axis is in millimeters. Does that need to be in meters?
yeah, technically it should be in meters.
Okay, but the newtons is fine, right?
Yeah, the newtons is fine.
Oh, so spring constant is newton meters.
Yeah, Newton meter -1.
What isn't newton meters like joules or not joules? Energy. Something.
Energy is
Work.
Newton meters.
Yeah, work and energy are the same, right?
Yeah. This is
Okay.
Newton meter -1, but work in joule is newtons times meters. It's actually a product.
Wait, what? What'd you say? Joules is newton meters? Newton times meters?
Yeah.
Yeah, and then energy is newtons per meter.
The spring constant is Newton per meter.
Yeah, so spring constant is in joules. Okay.
Huh.
Upthrust
Up there. They actually give you
is
this formula. I don't think. Wait, I do know it off the top of my head.
it's PGV, right? Or rho GV?
Yeah, it's rho GV. Where rho is
Rho
the
is
density.
the is rho the density of the material or water? Well, it's not. Now you know the density of water. It's the
Yeah,
density
in
of the
this case,
material.
you do know it's the density of water. If you think about it, so like in this case, like we're pushing the bobber down into the water, right? So the water is gonna push it up. So technically, our upthrust is going to be from the water. So
Oh, so the density is from whatever is doing the upthrusting.
yeah, you know what's crazy? Um, this is literally just the MGH formula, I think. No, wait, no, I'm crazy. Never mind. I disregard what I just
Isn't
said.
that gravitational potential energy?
No, this is the exact mass formula. Sorry, I lied. Not thing. Because if you think about it, density times volume is just mass. Why does this work? So density is equal to kilograms per meters cubed, and then
So it's
volume is
just
equal to so
it's just
PV is equal
mg.
to m. So it's mg, mass times acceleration, the gravity constant, right?
What is that? What G is? G is a gravitational constant.
Yeah. So this is how you relate. That's how you kind of just uh phrase the derivation of this.
Yeah.
And they also give you this formula, so it should be this should be a relatively easy problem. Um,
Elastic potential energy is that 1/2? Like, what is it? Like mx squared or something?
1/2 kx squared,
Ax squared.
or
That's what
I
it
should
is.
say delta x squared, where delta x is extension.
Yeah.
This is actually really important.
Ax
It can't be the
1/2
actual
k
original length, otherwise
a
it
delta
won't work.
x squared.
And I'm pretty sure there's another one. So if we expand this out, we can say like 1/2 k delta x, right, times delta x. So this is simply equal to force, right? This is from the Hooke's law, right? Or something like that. So then we have 1/2 times f times delta x. So you can also do that way. So like the compressed spring. So we know that the spring is what? The spring searching. Oh, we have a graph here.
This one question is 13 marks. Done.
Alright, you do have to determine the force. So once you determine the force, you can get the k, right? They actually give you k. And I assume after you get the force, you go to this graph, find the x. So let's say this is x, right? No, this is let's say this is m. You go over here, say m, and where is this? On the graph. Take this is n, and then slap it into here. So this is n times m times 1/2, and there's your answer. Does that make sense? I kind of like jumped all over the place, but like for these problems, they're like they legit force you to go back and forth on the paper.
Can you hear background noise from my mic or no?
No, not really.
Not really. Like you can't make anything out.
No, it's like every once in a while it sounds like a whisper, But
Oh,
it's
okay,
like
that's fine.
I can't hear anything.
Okay, good. Oh, 4 is waves. Dude, this would have destroyed me. I don't like springs. I don't like waves.
All right, so waves. I also hated waves because I didn't actually like learn it.
Wait, we did this, right? 4A?
Yeah, we actually did this. Yeah.
Easy. But yeah, wasn't he saying like wait, schedule.
Also, I hate this
Wait,
stuff.
what?
They say line, but the thing is, okay, so I don't know
Yeah,
if
this
you had
question
this.
was really confusing. I remember.
I don't know if you had like Janess. You know how she says like once you start talking about like a line, but that's like curved, she just like interrupts you, and it's like all lines are straight, and that really stuck with me because it says sketch a line, but on the freaking mark scheme it says curve, but like all lines are straight. So how is this a curve, right? And once you go into like Calc 3, like 3D geometry, like a line is very distinguishable. It has a very precise meaning.
Yeah.
And honestly, for this honestly like, it's okay. It's okay. It's okay.
All right. So 4A part 2. That's just a line, like the curve or the wave. But you just move it so that it starts at uh 0, but at x, right?
I,
Or wait. Period is no. But it starts halfway between 0 and x, right? Same wave, just halfway between 0 and x is where it starts.
yeah. So, this is 1/2. Wait. Okay, it says that 2 or 4. So I guess like this entire thing is T. So 2 or 4 is like right here. So then it's kind of like we take this wave.
Wait, Isn't t over 4 like t is it starts at 0 and goes back to 0, right?
All right. Yeah, it is 2. Wait, then why is it telling me? Why is that mark scheme saying that it's a initial negative displacement? Does that mean that it's like this? Oh god. Like that? Something like that? Like the first two?
Oh, I didn't even realize I'm looking at like the mark scheme right now. Like through the stream. I didn't even realize. I thought it would like actually show a picture of what it looks like.
Yeah.
Initial negative displacement, initial yeah, the same. I mean, as
Oh
long
wait,
as you
no,
draw
I
a
am
wave.
stupid. No, I'm stupid. I'm stupid. I'm genuinely stupid.
What?
Okay, so we know that this and this is t, right? This is t. This is one period,
Yeah,
right? So if we take here, this is t over 2. Got
yeah.
that. T over 2. And then right here is t over 4,
Yeah.
right? So we should start like right here, right?
That's what I thought.
Yeah, I guess, bro. This might be a ChatGPT problem. But I'm pretty sure it starts like here. I think this is what's intended. Because it says initial negative displacement, right? So it becomes like this.
Wouldn't that be minus t over 4?
Yeah. Or plus 3t over
Oh
4.
wait, no. Oh, it is. Wait. Oh yeah. It is because if you move you move it over t over 4, you have to add the part before 0. You know, does that make sense? I mean,
Yeah, I think.
like it's initially negative because like even though you're starting at 0, you're t over 4 into the graph already. You have to continue the graph from t over 4 to 0, and that is like that's under the that makes sense. You understand what I'm saying?
Mm-hmm.
You got it?
Yeah.
Okay. And then part 3. Yeah, this whole question was like kind of confusing. When he says state the direction, I guess the problem.
Yeah.
State the direction, isn't it either up or down? Like it's not talking about left and right.
Um
Or is it the other way around?
no, in this case it actually is left and right because it's a longitudinal wave. So
Oh, okay.
longitudinal waves longitudinal wave. Type of wave that moves parallel, right? The keyword parallel. And then you have the opposite is the transverse wave. So
So
this
transverse is up and down.
is what? Perpendicular.
The transverse particles in transverse waves move up and down, but particles in
Move parallel.
longitudinal waves
Yeah.
move
They also
left and
say
right.
like in the question it moves left to right if you actually don't know what it is.
Oh yeah, if you read the question, yeah, that
Yeah.
makes sense. Yeah, just read the
Yeah.
question.
Yeah. It's
Speed of the
stupid.
wave. B isn't it like c equals f wavelength or something?
V is
that
equal
right?
to F times wavelength. Where this is
Oh,
velocity.
v is equal to f times wavelength. Why did I say c? I mean, it still works technically, right? If you say c equals f
Yeah.
times wavelength, it's just only for c.
Yeah.
Okay.
Yo, if they give me
So
a problem like this tomorrow, I don't think I'm getting a perfect score. This is
really,
genuinely mind-boggling. I don't know. Like this sketching the line stuff, bro. they
Yeah.
just like say sketch a line, but it's actually a curve. So it's weird. I don't know. Maybe it's different in the UK, but yeah. Okay, so intensity.
Well, if there's anything about like the slit like the what is it? Wavelength equals ax over d. I
Okay.
know the formula. I don't know what any of the letters stand for.
Okay, I got you. I got you.
And
Like I
like
actually got you.
the degrees, bro, the degrees where it's like asking you like saying like the eighth degree maxima, like
Yeah. Okay, hang
it's
on.
gross.
I actually got you because the thing is, I didn't know how to memorize it until like I visualized it one way. So let's do the lambda is equal to x over d. Okay, so this is a double slit, right?
Yeah, d is the distance from the slit to the thing,
The
right?
whatever this is, right?
Yeah, I know that. And then I just don't know a and x.
So imagine you are right here, like you stand right here,
Mm-hmm.
and then imagine in this equation you stand in the middle. So to our
Mm.
left we have lambda, which is the wave, and then this right here is a, and then each one over here is going to be x, and then over all of this is going to be d. So we have lambda is equal to a multiplied by x divided by d.
Wait, so what is a?
A is the distance between the slits, I think.
Oh, it's from it's from this is the distance from the center of the slits. Remember. Okay. And then the Maxima stuff, I don't want to I don't want to I don't care.
Now,
I'm just not
honestly,
gonna do
if you
that.
okay, wait, let me show you the max now. So it's like NF, right? No, it's n lambda is equal to d sine theta.
N
So
lambda is equal to d sine theta.
so this is the wave, right? So n, you just want to think about it like the actual like number. So this is the number. This is the nth order maxima.
Okay.
So if they ask you first order, it's going to be the one order. It's going to n is equal to one.
And
First
what's
order
lowercase
maximum.
d?
So let me get to that. So lambda, self-explanatory, is going to be wavelength. I don't think there's another lambda. So d is a little bit weird. So d, you want to think distance. So it's going to be like distance per line. And what this refers to is like, you know how it goes on like a grading and you have like maximas and minimas? So d is
Yeah.
just simply like, I think it's like this. It's like distance per line. So then the units is just going to be meters. This is like really important that you know that it's like meters over line because they sometimes give you lines per meter. Does that make sense? So like sometimes a
Yeah.
question is asking, "Hey, how do you calculate this?" And then they give you like lines per what millimeter. This is
Yeah.
annoying because then you have to calculate this into like 1 times 10 to the negative 3 is equal to x lines, and this is what d is equal to. So yeah, this is like if you don't get it now, it's fine, but you want to make sure that d has units of m meters.
Yeah.
Yeah, and then like sine theta is like, let's if we look at the if we look at the diagram, theta is just the angle of the like the fraction. Does that make sense?
Yeah.
All right, now how much of these are you actually gonna remember for tomorrow? This one
I'm definitely gonna remember that one.
this one, yeah. I hope you memorize this one because this is like one of the most intuitive ones. You just literally
Yeah.
stand in the middle, say ax over d. So like
I
you go
think
left, right, over left, right, bottom.
I think I'll remember the and lambda equals, or wait, maybe I won't.
Yeah. I
What
mean,
is it?
if you already memorized this equation, you're already like halfway there. So
Wait, how did I forget the other one? Oh wait, it's n wavelength equals d sine theta.
yeah.
Yeah. Okay. I think I'll remember that one, but if it's like the thing where you're saying what you're talking about, where it gives you the lines per meter, or yeah,
Yeah.
lines per meter, I don't know.
Okay.
We'll see.
Yeah.
But I'm looking at 5 right now. 5b. 5b part 1.
Okay. Three identical cells, each of which is 1.5. So internal resistance is this, are connected in parallel. The total resistance is this. Show that the resistance is 2.0 ohms. Um. Oh yeah. Okay.
You need to do current. Find the current.
No. So you want to think about these internal resistance as like parallel resistors.
Yeah.
So then essentially we have like
Oh, do you literally just do the 1 over
yeah.
0.59 plus
So
1
1
over
over
0.59
5.9
plus 1 over
times 10 to the negative 3, right? And then we have 3 of these, and then you have to take the reciprocal of this, and this is like your total internal resistance. We'll call this like small r. So then you do like 2.2 minus small r. That's going to be equal to 2.0 ohms, which was to be shown. I think that's essentially the idea.
Okay. Oh, and then current. Current in the conductor. Voltage. Well, the voltage of the conductor is 1.5, right? Or no? No, I don't
Bro,
think
why
so.
is Felipe Martins telling me to play Fortnite with him right now? That's too good. Yo, we started stream 67 minutes ago. Hi.
Alright, that's a sign, bro. It's time to end.
Time to end? Okay, I'm going to sleep.
67 minutes. So, how do you know? Is the voltage of is the EMF the battery 1.5 volts or no?
Yeah, the EMF of the battery is 1.5 volts.
It's 1.5 volts because all the others are 1.5. I mean, the EMF of the conductor. Voltage of the conductor. Is
The
that
conductor.
1.5?
I think it is, yeah. Yes, because like based on like voltage, right? Voltage is like the same
Yeah, voltage is the
across
same as parallel
parallel.
resistors. It's like they're sharing voltage kind of, because what is it, like some of the, because of Kirchhoff's second law, some of the potential differences, some of the electromotive forces, like all the parallel resistors are acting as one resistor, so it's
Yeah.
like 1.5,
I think
and
there is
then
a derivation of this, but yeah.
something like that.
Yeah, because you know how like the resistors like 1 over RT? It was like 1
Yeah.
over RT is equal to 1 over R. 1 plus 1 over R2. Dot 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 1 over R to the n. If we multiply everything by volts, you just get Kirchhoff's first law. It's like IT is equal to I1 dot 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 to IN. I think, right? No, this is like loosely related, but this is how you derive the parallel resistor formula. but it also shows you that if we you can't really prove this, but this is just the way it works, is that if we multiply by v and we get like this perfect thing, that means that multiplying this everything by v must be like a good value, and that this value is
Alright,
shared
bro.
across
What
everything
you're
else.
saying.
Okay, I don't even know what I'm saying either. I'm just like LARPing, bro.
Okay, now I'm looking at part C, and I don't even know twin.
What is this? R. What is R? Resistance?
Yeah. Oh, what is this? Is this resistivity is resistance times area over length?
I don't think so because they don't give you
I
resistivity.
don't think so either.
Honestly, I think this is more of a I is equal to NA
EQ.
EV type thing. Wait. They don't give you drift speed though. So I wonder how they do this. Oh, they do use this.
Wait, let me see. I equals A and VQ, yeah. Okay. Current, yeah,
Yeah.
current's equal.
And
What is
then
N? The number density?
yeah, the number density.
And how do you
And
know that's the same? It just is because it's the same wire.
yes, I think so. So
And
then
then
you
Q
just
is, I mean, Q has to be the same. It's always the same.
Q is the elementary charge, so it's a
Yeah,
constant.
yeah. So it's just A. Okay, and then, well, yeah, so you know everything else, so that's how you know the ratio.
Yeah, and then so that means that just like V is like
What is it? What do they do for part two? Oh, that is part two. I'm looking at part one. Yeah, see?
oh, I am
There it is.
stupid. Oh, it is.
Yeah,
How is it
R
resistivity
equals.
though?
I don't
Yeah.
understand. Oh, I guess it's because the resistivity is the same and the length are the same.
Oh yeah.
But I low-key don't understand why is resistivity the same? Because resistivity is proportional to size, like area, I
I
guess.
think resistivity is like based on like the actual material. Yeah, it's the material.
Oh, okay.
So then you can just say like it's a constant because they're the same, right? And then they
Yeah,
just cancel out with each other. Huh.
yeah, I kind of knew that. That's why I said it was
Bro.
what I said.
Yo, I am out of it, bro. I think
What
it's
is
time for me
what
to
is
go
the
sleep.
crown
Huh?
in the stream chat? What does the crown mean?
The crown means like your top fans.
Oh, Felipe is your number one fan.
I guess, bro.
Oh, Felipe's gone, bro.
Yeah, I know he is. It's okay. Bro,
Okay.
where are you typing, bro? Aren't you my number one fan?
Um, not on this account. I
Wait,
usually
are you
watch your
18?
videos on
Are
my
you 18
student
yet?
account.
You can start an OnlyFans.
Man, this is live, bro.
Oh, my bad, my bad.
You just log in. Okay. RD, remove one of the cells. Removing one of the cells would affect the whatever the 1 over like
Yeah,
what is the 1 over like when you do 1 over 590 times 10 to the negative 3? Oh, that's resistance.
yeah, resistance.
Yeah, so removing one of them would affect the resistance.
Yeah.
And changing the resistance,
How will it affect the resistance? Will it
No, no,
increase or
no.
decrease?
It's asking about how it affects the potential difference.
Yeah. So
But if you
how?
increase resistance, you increase voltage, and decrease resistance equals decrease voltage. Right? Because V equals IR.
Yeah. It's actually the opposite in the mark scheme.
Oh, what does it say?
Well, let's look at this. So the combined internal resistance will be greater because we're removing a parallel resistor because parallel is like reciprocals, right?
Hmm.
So more internal resistance, take a greater share of the PD. Okay, whatever. I don't think we ever get
Internal
that.
resistance.
So
Take a greater
conductor
share.
gets a smaller share of the total PD. Okay, now let's just go with the current because we said internal resistance will be greater, right? So the total voltage is because you can say like V equals IR. So V is equal to IR.
Mm-hmm.
If R increases, that means the current decreases. So then the potential difference, because it's like this, right? So if we have our thingamabobber, if we have our I, we can say like the incoming I decreases. So our potential difference here, um, V is equal to IR, right? This becomes lower. Okay, wait. I should say this is like EMF. Does that make sense?
I tuned out after you wrote down V equals IR.
Alright, so we increase resistance.
Yeah, increased resistance decreases current, and then after that, I was going.
Wait, so now we were looking at the entire circuit, right?
Yeah.
So we got to focus on the actual conductor.
Mm-hmm.
And we say that we have our current that we got, but it's reduced.
Yeah.
So if we use the V equals IR equation, our R does not change in the conductor. But we
The
said that
current.
our current
Wait,
decreased. So then
wait.
our
Why is our
PD,
R the same?
huh? Because the R refers to the R, the resistance of the conductor.
Okay.
So this is like PD. So our PD is decreased.
Okay. Oh, and then 6 is
Yeah.
beta decay.
Is that the decay we did? No. But yeah, so this is how you write the antineutrino. You can say like this or this. This is like interchangeable.
Yeah, hat. Antineutrino is the hat.
Yeah.
So what? It would just be 0. Well, that I don't like that. I don't like how it has the E minus.
Yeah, I don't like it
I mean,
either.
it kind of makes it easier, but like it feels like if you put 0, -1, then it's like -2 total. You know what I mean?
Mm-hmm.
But that's what it is, right? It's 0, -1, and then
Yeah, you can do
what?
beta minus, E minus. It's
14.7.
technically an electron, I think.
Yeah. I mean, it says E minus. It's an electron, and it says in the question too. So it's 0, -1 for the electron, and then 14.
Yeah.
14 what? 7?
State the equation for beta minus decay in terms of fundamental particles.
14.7, right? Yeah.
How does that? How do they expect that? I'm genuinely curious. D?
Oh, yeah, what? Okay. What
Wait,
does it
this
say?
is so weird.
Ah, a
How
stop
do you
sign.
state an equation like this? I've never seen this before.
Or up,
This is
down,
not our region,
down.
right? I hope this is not our region. God damn.
No, this was 3. Is 3 our region?
No, we're one.
Yeah, okay. I don't know what they're talking about. Never
Yeah.
learned that.
But
What's your
yeah.
equation from
I think
well,
that
whatever.
you should know this, but like like you should
Nah.
know this for the exam when you do this. When it becomes beta decay, you should know that down quark turns into up quark. That's the main idea. And then use your equation to show how charge is conserved. Bruh, like... Okay, whatever. That is actually so straightforward. It's not crazy.
Yeah, okay, now I'm looking at part C. Beta decay energies are continuous, right? For CI.
Yeah.
And then neutrinos have energy. What? So
Also,
therefore
you should
beta
say that it's continuous range, as it says in the mark scheme. I think that's more precise. Continuous range, because even though it because continuous is describing how the graph is plotted, but like, wait, you know what? You just forget what I just said. My English is like chopped right now because my brain is fried.
beta particles have a range of different energies. That's all you need to say, I guess.
Yeah.
That's
Yeah.
it. Oh
Yep.
shit. That's it. It's crazy.
No cursing.
Okay. Oh frick.
We're live, bro.
Oh darn.
Oh, okay.
Cut chat or editor. Can you cut that out, please?
Yeah.
Dude, we're gonna lose. We're gonna lose our monetization, bro. Oh my
Oh
god.
yeah. When there's only one person
No,
watching right
no.
now, which is
Oh
probably
wait,
just you.
clicking on the crown doesn't like work. I think it's supposed to take me somewhere. But clicking on the crown, like at the top, it says I have 0 XP.
Yeah. You're a bum. Oh, it says that
So
two people are
sad.
watching.
I'm a
Hello,
lurker.
hello, other person.
A lurker.
Welcome.
Yeah, 82 minutes in. We're at the end, bud. Just leave now. Okay.
Are you gonna go?
Well, yeah.
Okay.
Time for me to sleep.
I'm gonna sleep too. I'm tired, bro.
3. How about you? How about you? 3. Oh, there's 3 watching now.
Hello.
Chat, are we tired?
Are we tired?
Chat, are we tired? Chat, put your answers in the chat if you're tired.
Oh look, it's Ari.
Are you tired?
Are you tired, Ari?
Are you tired, sir?
We've been at this for 82 minutes.
Yeah, it's time to go to bed, Ari.
Look at this cool notes that I made.
Yeah, you're kind of too late, Ari. Or it's all over. Unless you're gonna watch from the beginning, and then you'll finish at
I could probably watch on 2x
11:40.
speed. Nah, he got that.
Oh, he's
Yo,
not tired. Oh wow, within 2 typing 2 messages gave him number 2. Wow,
this guy
incredible.
is crazy.
He's going insane. And now there's 3 watching, so there's another one.
Hello.
Third viewer, are you tired right now?
Are
Type in the
you?
chat if you're tired. Hey, yo, everybody, type 1 in the chat if you're tired. 1 in the chat if you're tired.
Yo, Francesca.
Oh, Francesca, yo, can we get that? Can we
Are you tired, Francesca?
yo, Brian, can you
What? You want me to end stream?
oh no, like maybe get Francesca out of here. I don't know, she's kind
Yo,
of really
I don't think I have the authority to do that.
what? You totally do. This is not Teddy. Do I sound like Teddy?
Whoa. I
That's what I'm saying, bro.
oh
Like
my
you
god.
can't click on her name and like kick or attempt ban like you can in Twitch.
I can add her as moderator. I
Oh,
could
dude.
remove
Oh,
her.
wait, add me as moderator.
Oh wait, I
Or,
can
well,
put
can you even
put
do
her
that?
in timeout.
Yes, time her out. Wait, let me see. Let me look at at the Discord call. Okay, stream what it looks like so I can see what you can do. Wait, can you even show your stream menu? Oh yeah, okay. He is moderator.
Yo, put user in timeout. Yo, that's fire.
Remove.
Remove.
Oh wait, click it again. User in timeout. Wait, click on it.
Ooh, a 10
10
minute.
second. 10-second timeout. 10
10
second
second
timeout.
timeout.
He's probably
Yo,
gone at this
that's
point.
crazy.
Oh no, there's 5 watching. Dude, we're peaking. Why are we peaking at the end? Bro.
Yo, we are legit peeking at that. You guys are night owls.
Okay, no, we need to get for a real timeout. Just a baby. Real
True.
timeout. Brian, timer out for I don't know. What are the options again?
Uh,
Pull up the options.
10 seconds,
Yeah,
1 minute, 5 minutes.
5 minutes.
Nah, I can't do that.
1 minute.
Wait, I need to ask them. What do you guys want to study? Because I went over nuclear. You can probably go back and watch that. And I went over a little bit of
Yeah. Nuclear, we kind of reviewed springs and waves a little bit.
oh yeah, I
And
kind of reviewed this current stuff.
yeah, a little bit of current, springs, waves, current, radiation. Did we do anything else? Moments. We did a little bit of moments. We did Kirchhoff's laws.
We
And
didn't do
I think
this.
that's pretty much it.
Yeah, we went over. Oh yeah, we went over this diffraction stuff.
Oh yeah, a little bit on diffraction.
Okay,
Wavelength
do
equals ax over d, and wavelength equals d sine theta.
yeah, these are actually like okay. So I taught Teddy how to do this, and this is like really intuitive. So like, imagine like you stand in the middle here. You have the double slits, and then you have like your grading, right? So if you stand in the middle, you just this is like exactly your equation. So we have lambda, which is your waves, is equal to the A, the slits, multiplied by X divided by D. So X is like the distance between the grading, and then D is like the distance between the actual wave emitting and this thing of a bobber.
Why is this low-key fun explaining stuff?
I don't know. Maybe that's because what?
Right?
I can't
Should I
English.
start doing collab videos with you, Brian?
Uh, yeah, let's do it. Let's do
What are we doing next? I'll come back
Terraria,
as a
bro.
super senior and we can. Oh, yeah, you were
Terraria,
gonna
bro.
stream your Terraria. You know what? You know what? Let's run it right now. Right
Right
now.
now,
Right now, till 1 a.m.
till 1 a.m. I'm down, bro.
No. Hell.
Teddy the
Yeah,
teacher.
was that
I
supposed to
don't
be
think
funny,
Teddy is ever
Francesca?
becoming a teacher.
Think you're funny? You
I'm
think
gonna
you're
be for
funny,
real.
Francesca? Because it rhymed. Because of the alliteration.
TT. Yo, Teddy the what? You got triple T? Like triple T?
Scribble T. Teddy the tongue.
Teddy the terrible teacher, triple T. The
Mm.
terrific teacher.
I don't know. What's a noun that starts with F for Francesca?
Uh frivolous.
And that sounds like a title. That's not what? That's not a noun, bro.
Oh, I thought you were asking for like a
Okay, I don't know what you're talking about, bro.
alright.
But yeah, I'll come back as a super senior whenever you're taking. What math are you taking next year?
Calc. She said fantastic.
Again, Francesca, we're looking for a noun, not an adjective. Thanks though. Yeah, maybe you want to put up the definition of a noun on your stream. Right.
Yeah.
Yeah, for Francesca, it seems like she's unaware. But yeah, I'll come back as a super senior, and we can do calc problems.
Calc?
Yeah, right. Are you gonna take calc next year?
Oh yeah, I am. Guys,
Oh,
if
there you go.
anything from units 8 through 15 show up, I'm done.
That
Oh,
what you said?
wait,
Oh, you said,
I
or
need
is
to
that
look
what
at
she
the
said?
syllabus.
8 through 15.
8 through 15.
Whoa,
What
whoa,
unit is that?
whoa. Yo, that's crazy, Francesca. Aren't you
Cheat?
going to like an Ivy League, bro? I might screenshot that.
Bro, already went over nuclear physics.
What's chapters 8 through 15?
I don't freaking know.
Who's the Waffle House?
I don't know. I think that's Matthew. Honestly.
Is it Matthew?
I don't know.
Waffle House, type 1 if you're Matthew.
Oh, waves, electricity, DC circuits, particle physics.
Oh, dude, potential dividers? Like that stuff,
Oh
galvanometers,
yeah.
potential dividers. Oh my god.
Yeah, I think I'm gonna
It's
give up on that. Actually,
over.
I didn't review any of that.
Yeah, if there's
Bro,
anything on potentiometers and galvanometers,
out of every single mock I did, there was nothing on that, and I feel like it's gonna be on there. Maybe I
oh
should.
yeah, it's gonna kill us. We're dead. We're dead. We're dead.
Guys, all I did was read the book, and I'm only halfway through. Bro, Francesca, you're supposed to do
What are you doing?
problems.
Like you haven't like Francesca, you took the class, bro. What do you mean?
All right, don't listen to Teddy, bro.
Why do you need to read the book? No, but like you don't need to read the whole book. Like you just read the book for what you don't understand already.
Yo, I think my nail's falling off. What do I do?
Unless she doesn't understand the whole class, which I guess she's kind of
Internal energy. Wait, what? Do you go with thermo?
internal energy. You're doing calorimetry.
Ew. You learned this in chem. This is annoying.
Are we doing calorimetry on the test?
Yeah, Q equals MC delta T, bro.
Yeah,
No, I am
we're just
taking
making up
screenshots of
words,
my
huh?
eyes. Ah, photographic memory. Couldn't be me. What is a capacitor? Oh. Oh yeah, you know
Ooh,
what's crazy? There's actually something bro, Mr. Lee was like telling me I'm just a bum. But actually not a bum.
what?
Look, did you know that this is a heater? I've never seen this. I've never seen this in my life. I swear I've never
Huh.
seen this in my life. Heater, like this heater symbol for circuitry.
Oh, yeah, I was gonna say that. Like, we're supposed to have all that stuff memorized. It's raps.
Yeah, I think that.
Oscilloscope? Like what?
Yeah, I think that's A level. I hope that's A level.
Yeah, I hope so.
I thought I would study these past few weeks and then I fell asleep. Man, senioritis is really hitting you hard, man. I don't know what to tell you.
You fell asleep? I don't think falling asleep for weeks at a time is healthy. I don't think that's normal. You might want to go to the doctor. Yeah. I mean, I don't. Usually I sleep for like 8 hours. I don't know about weeks. I mean, did you miss school? I guess we got out of school. But you might want to get that checked out.
Bro, it's nothing too bad. Bro, I remember sleeping at like 2 a.m. every single day. That stuff was like actually kind
But
of.
yeah, but she said she's sleeping for a few weeks. It's like a coma. How did that happen, Francesca? Why are you laughing, Brian? And why are you laughing at Francesca?
Yeah, I'm laughing at
He,
Francesca.
he was in a coma, Brian. It's not
Yeah, with
funny.
the IV too. Were you thirsty when you woke up?
That's what I'm saying. Like, you gotta be really hungry and really thirsty, or unless I had IV, like Brian was saying.
I bet we'll see a number to the power of 0 instead of a degree symbol. Hmm.
Is that ball knowledge, Francesca?
That is ball knowledge, bro. I got that reference.
I remember that. I remember that test because I got everything right, but I didn't put meters on the 9, so it didn't count, and I got a 4 out of 5.
Oh my god.
Was actually devastated.
Suffering from success, bro. SS, bro.
All right, Brian. Roll the outro music.
I don't have any. I don't want to play copyright music. Bro, did you listen to Drake's new album? I look, you
Bro,
listened to like 2
I
songs.
heard enough. I heard enough from Instagram Reels.
Oh
Hey,
yeah?
if I sing it, I could low-key get you. I sing it so well, you'd probably get copyright striked.
Oh yeah?
Um,
Bro, I listened to like 2 songs and they weren't bad, but like they weren't crazy.
no, they were 2 of the albums were really bad, and he just put them out so he could get out of the deal, right?
Probably.
1%. Wow,
1%.
always wait until the last minute, apparently. I'm sending that to whatever college you're going to. You're done.
Alright. Goodbye,
You're
Francesca.
finished, Francesca. Play the outro music for Francesca.
See you tomorrow. Bro,
Right.
wait, what room are you in?
Look up non-copyrighted outro music to play for Francesca. Francesca, you have to wait for the outro music. Oh, there we go. Wait, that doesn't sound like outro.
Wait, can you even hear it?
Well, I don't know if I can hear it through the call or through. Well, I have your stream muted, so I don't know. Do I have a picture of my testing ticket? I do.
There we go.
I don't know. It does not sound like outro music. 7:30 a.m. I'm in Portable 2. Where are you?
I think I'm Portable 12.
Oh, we can hear it, Brian. Who's Waffle House?
Bro,
Is it
I don't know,
Matthew?
bro. I don't know.
For some reason, I feel like it's Eric, but I don't know. I don't think Eric would be watching this. I think Eric's cooked. Shout out Eric. Rest in peace.
Poor guy, bro.
Waffle person. Can you type your initials in the chat?
What is this, bro? You know what this? Oh, it's Brady. Hello, Brady.
Oh, what is the initials?
Brady. BB, bro.
BB.
He's a junior.
Yeah, okay, I think I know. He sits next to Matthew, right?
Yeah. You know what this sounds like? Like this music? It sounds like one of those like
nothing.
tech videos, like like those infographics. Like those one of those infographic videos, and then like there's some white guy at the end, like wrapping everything up. This is what it sounds like.
Yeah, sure. Yes, man.
No? Okay. I guess I'm a bum, I guess.
No, I just don't really know what you're talking about.
Is this fire?
Wait, Brian, who are we gonna raid? Who are we gonna raid?
Yo, who are we reading at this hour?
Are we raiding Laufey or whatever?
Yeah, I don't think she's live, bro.
She's probably streaming. Doesn't she stream every night, bro?
I don't know. I am not a hardcore Levy fan.
Uh-huh, sure. Well, you know how to say her name right, so...
This is
Pretty safe,
Boston.
man.
Oregon Boston.
What am I looking at? What is this? What are you doing on? What is it?
Yo, I'm listening to outro music.
No, what is the tab? What is that thing in the like? What is the software?
What, this?
The black circle in on your taskbar. What
This
is
is
that?
OBS.
Oh, OBS. Okay.
Yeah, just don't look at it.
Just huh?
Yo, I just like how this profile is called gay. I don't even know who said that.
Where?
The
can't
profile,
see
it
it.
says gay.
Oh, Okay. Huh. Okay. Can you roll actual outro music or
No.
not a lo-fi outro, like real outro? Oh wow, my shit is so popular.
What are we doing, guys? Brady said we can raid Matthew's fridge. Does he
Okay,
have good
wait.
food
So
in there?
can you can you play real outro music, bro? Like scroll down.
Like what?
I don't know, like the
Huh? Wait, like this guy is trying to like you know how like you search by keywords, trying to hit every single one of them.
listening to right now.
Yo, what is this?
This is
Yo, what
this
is
is the
this?
this is the Bumblebee outro.
Bro, this sounds like a garage band,
Mmm,
bro. Yo, that's fire.
that's tough.
That's tough, bro. I think I'm downloading this one, guys. Donate? I don't think I'm donating on this one, guys. Bro, I don't know. Can we just enter? All right, let me ask Brady. Do you have anything you want to go over specifically? Oh wait, he's already gone. Never mind. Okay.
Done. Okay, Brian, time to end the stream.
Yes.
Pull the outro music.
Rain, go away.
Pull the outro music.